Hello and welcome to my presentation on the different structural engineering focuses that are offered here at UC San Diego. So the very first focus we have is civil structure. Civil structure basically is a sequence that aims to design, analyze, and construct infrastructure, and this is what the wider public interacts with on a daily basis, things such as roads, office buildings, and homes, and basically in help ensuring their safety. So a general overview is some common questions: how to optimize material usage while keeping costs down, how to ensure maximum load capacity. Some major problems are having to avoid resonance within a structure, as well as dealing with aging infrastructure, especially here in America, what to do in terms of either retrofitting or creating new infrastructure. And some major projects that engineers work on are bridges, canals, and railways. A possible career would be in analysis and modeling to specialize, which specializes in understanding how structures behave under various loads and environmental conditions, and using mathematical models, simulations, and physical tests to ensure that these structures are safe, efficient, and durable. Now, the next focus is geotechnical. This examines different soil conditions to ensure that the foundation of a structure can safely disperse the loads that act on that structure and is necessary for the safety and longevity of a structure. Now, case study is here, the Leaning Tower of Pisa. There was a massive undertaking to stabilize the tilt of the tower so that it didn't collapse. There was massive cables that were tied to it, as well as weights and soil extraction to help make the tower lean more straight and then help it settle. And so thanks to the work of these geotechnical engineers, people are still able to visit this great architectural piece and interact with it safely. Now, some general info. Some major questions are: how do different soil types affect foundation design, as well as what type of foundation should be used? Problems are things such as soil instability and groundwater interactions, how soil and water interact, and the consequences that has on buildings. Some major projects would be the Three Gorges Dam, the Millennium Tower retrofitting up in San Francisco, as well as the London Underground or any other major underground railway network. Now, the third focus, and my favorite, is aerospace engineering. Aerospace is all about creating high-performing, durable, and redundant structural systems for aeronautical ventures. And so this is necessary in facilitating the safe transit of billions of people every year. And a common failure that we've learned about in SE1 is buckling. And so this because of the fact that aircraft have many slender columns and beams that can undergo compression during flight. It is a crucial design consideration that needs to be taken into account for structural integrity purposes. I love this sequence the most because it is on the cutting edge of innovation, and as air travel is extremely important and will become more important in society, it's more important. It's also important that in order to make it a net benefit, a greater net benefit for society, environmental sustainability should also be taken into account. So a general overview for what aerospace engineers do: they help reduce aircraft weight without compromising structural integrity, and so as well as figuring out how to effectively transfer loads within a closed system. So the main problems are having to balance performance, reliability, sustainability standards, and within strict defined design constraints. And some heavy projects, or some projects, notable projects, are the Falcon Heavy, as well as the F-117 Nighthawk. Now, the last sequence is structural health monitoring. This facilitates the data acquisition using sensors and analyzes the condition of a structure and while performing data analysis. It's very important because it can tell early signs of failure and give greater insight for maintenance and the life cycle of a structure, and can potentially help save costs and even lives. Now, a summary is, what type of sensors should be used or how to integrate structural health monitoring into maintenance. Some common problems are having to figure out crack detection and interpreting large swaths of data. Some projects can be sensors on bridges or using alert systems to figure out possible problems. And a possible career path would be in historical building maintenance and figuring out how any upgrades that can be done for historical buildings to ensure that they have structural integrity, and also using data analysis methods for that. Thank you so much for listening to my presentation. And I hope you enjoyed. Thank you so much.